All right. Thanks again for joining today. My name is Ben. I'm on the product marketing team here at Sentry, and I'm joined by Francesco Novi, who's a senior engineer here at Sentry that works on our JavaScript SDK. Today, we're going to walk through how to get started monitoring your Node.js project with Sentry. So some quick housekeeping before we get started. Please ask your questions throughout the session and put it in the Q&A tab within Zoom. This makes it much easier to sort through so that we can answer your questions at the end. And number one question I always get asked is this going to be recorded in case you need to jump off early? Yes, and we will share the recording with you after through a follow-up email. And when you leave today, we're going to send out a survey. It should pop up within Zoom. And please share your feedback. We read through every single comment. So we're going to take a few minutes just to quickly share an overview of Sentry for those that are new. And then Francesco is going to jump into the demo that's going to show you how to set up your Node.js project, send custom context to Sentry. And then he's going to show an example of how to debug an error and also using tracing to search for an issue across spans, and then how to monitor performance. And then he's going to walk through how to set up alerts. And at the end, we're going to run through, I think there were 5 or 6 questions that were asked when people were registering. So we're going to answer those. All right. So first, I'm going to give a quick overview of Sentry. So with giving a quick overview of the observability landscape, I'm going to share where Sentry fits in. And if we break down the observability landscape into 4 pillars, security, data, and infrastructure pillars are really important to helping your DevOps and infrastructure teams monitor systems and services. However, bad code, as you all know, drives a lot of these issues. So this is where that code pillar comes in, and this is where Sentry is focused. So Sentry is built to help developers reduce debugging time by helping them understand the root cause of an issue. For many organizations to innovate fast, developers have to be constantly shipping code. And this means that the code is the fastest changing layer in your stack. And as developers are typically managing the code, they are spending more and more time monitoring, sorting through disconnected tools to view things like dashboards and logs to find and fix issues. So for developers to spend less time monitoring, debugging their code and more time shipping, they need to know the when, what, and why behind issues fast. So like solutions that are built for DevOps that monitor your systems and logs, Sentry is purpose-built for developers. Sentry delivers code-level insights to help you identify the root cause of an issue so that you can reproduce and resolve bugs faster. So to wrap it up, Sentry gives developers opinionated code-level visibility from pre to post-release so that you can find and fix errors and slowdowns and therefore deploy with confidence. So for example, when an error slowdown does occur, Sentry's tracing connects issues to the code to automatically detect the when, where in your code, and the why the issue occurred, including details like the commit that introduced the error, the code owner, and what the user saw leading up to and after they experienced the issue. So this is all meant to help developers see what actually matters and solve the problem faster. All right, that was my quick overview of Sentry. Now we're going to go into the product demo. All right, Francesco, take it away.
Cool. Hey, everyone. I'll show you how to set up a simple Express app with Sentry today. So let me share my screen. So here we have a very simple Express app. It does nothing really fancy. I just set it up with a few example routes. So we can run this app and it will generally work. I made sure to include some fetch calls, which you may do in a regular app. And yeah, so it's a simple app, no Sentry to see so far. So let's say I want to add Sentry to this application now. I would start with basically creating a project in in Sentry. So this is an Express application. So I'll select that. Since I'm just demoing this, I don't really need any alerts for now. And then I give this a good name. This sounds good to me. So yeah, now we have a project in Sentry, but we haven't set it up yet. So you can see here already that there are some insights here. We will not follow this directly here, but I will just show you the most important aspects of this. So the first thing we want to do is we actually need to install Sentry Node. So let's do that. So this is a dependency that's added, and it's really the only dependency that you need to get started. Once we have that, we need a DSN. So that's basically the project identifier that's generated per project. I will copy this here because I will need this later when I actually set up the project. So back in our code, what we will do is we'll create a new file that we call instrument. Yes. And this file will contain all the Sentry instrumentation code that we need. So I will start with requiring Sentry node and then calling Sentry init. This receives configuration basically, but the only really required configuration is the DSN that we just generated. And I will also define a traces sample rate because I also actually want to capture traces and performance data. Really, that's all we need to configure the Node SDK and generally get started. So now we have the config and the initialization of Sentry in a separate file. And what we then want to do in our application file is we need to load this file. And one very important thing to notice here is that this file has to be loaded before anything else is imported. And then afterwards, we can actually require the rest of our application. And that's important because Sentry can only instrument things that are required or imported after Sentry has been loaded, right? So it's important to first have all the Sentry init code, and afterwards you can require Express. So this example is based on Express, but it would be the same basically for any other Node application. So with this, I already have kind of basic Sentry setup. I actually also want to capture Express errors properly. So for this, I can also add the Express error handler. So I pass my app into setup Express error handler, and this will set up under the hood everything I need to actually capture errors for my Express app. And that's basically it. That's all the setup you really need to get started with Sentry. So let me actually run our application now and try it out. So here we have an application with a few routes that are defined. So I have a random route and that works, I see. I get some output here. Can call this a few times and it seems to be working. We also have a route that allows us to define how many characters of a random string we want to have. And if we call this, we actually see that there's an error. So something went wrong here, and I would actually like to figure out what went wrong. So now I can go back into Sentry. Let's look at the project that I just created. And here I can see that Sentry actually captured an error for me. So any error that is captured automatically gets into the issue stream in Sentry, which is really like the central place where all the problems that Sentry detects in your application are sent to. So I see here, okay, something went wrong. And I already here on the overview see some data on this. So let's imagine I run this more often because maybe users are running into this error. If I go in here, I can see that I don't have now multiple entries for this error, but I still have just a single entry in here. But I can see that it happened actually 6 times. So this is like a critical part of the issue stream, that we really group stuff together intelligently for you, so that you actually see stuff that kind of is the same thing grouped together. And you can also see the impact, because you can see, hey, if this error happened 10,000 times, then it's maybe more important than if it happened just once. I can also see here where this error kind of came from, and I see that this is actually parameterized. So I don't see the actual URL because I called this with 10, but users may call this with different parameters. But this is all grouped together into a single thing. So let's look at this error and try to figure out what actually went wrong. So looking at this, I see some metadata, but very importantly here, I actually see a stack trace. So I see the error and I see, okay, I tried to call toString, which is not a function. I guess this was a typo on my end. But here I actually can see that this error comes from line 47 in my file, which is great because now I actually know what I need to fix this, because I can go into my app and actually find the problem, which is this, and fix this and ship this to my users. That's really the core of error monitoring. All of this happens out of the box under the hood for you, and you don't really need to configure anything else in Node to get this working. You can also see some breadcrumbs here, which kind of shows you like stuff that happened before the error happened. For example, you see here that we did an HTTP request. So in this scenario, the HTTP request did not lead to an error, but often errors are related to other stuff that happens in other systems, like, for example, through an HTTP request. And the nice thing about this is that Sentry also actually captures stuff that connects things that happen in your application with a trace, which I can see here by clicking View Full Trace. So if I click on that, I can actually see stuff that happened during my request. And I can see, okay, there was some error during the HTTP server request for random /length. And I can see that I did an HTTP client request to example.com here too. And I can actually see how long all of these things took. So this also leads into performance monitoring, because I can actually use this information to see how long my API routes take. So it can sometimes take some time for data to show up here properly. So in this, so you can see all of this nicely. So here I can see that before I actually went on 2 different routes. I went to the random route and the random / some number route. These are automatically grouped together, and I can actually see aggregate data for these different routes. And I can, for example, see which route on average takes longer to process and which is faster. Now, this is obviously a very simple example, but in reality, if you run this for a longer period of time, you can get very good averages for your API requests. And you can actually see, hey, this is maybe an endpoint that needs attention because it keeps getting slower in certain scenarios. You can also see how many of these endpoint calls had errors. In our case, since there was just an error in the function invocation, every invocation of random / some number led to an error. But in the real world, often you have just errors that happens under certain circumstances. So you can also see this here. And if I look into that again, I get a better breakdown of every single thing. I can see how long certain invocations are. And then I can also look into samples for these, which brings me back to the trace view, where I see everything that happened leading to this. Importantly, this can also be connected. So I have an endpoint that actually makes a request to another endpoint of my own application. So that's the connected route. And if I look at that in the Traces Explorer, for example, where all the data comes in, I can see here my connected call. And if I look at that, I can see that my connected API request makes a request to the random route. And then I can actually see what happens in the random route. So I can really see everything that happens, even if I have like a microservice architecture or something like this, all the stuff will be connected together. And this would also be connected together if the services would be completely separate services. So in this scenario, all of the routes are on the same service, but you could also have different services that talk together. Let's just to show how this looks. So this is all the code that I have in my application, where I just have a regular fetch call, and all of this will be instrumented automatically. You don't need to actually do anything about this. Sentry will do that out of the box. Yeah, that's basically it. So I just mentioned this is the Express example. Express will be instrumented automatically. You don't need to configure anything here. The same is true for a variety of other frameworks. So we also auto-instrument Fastify and Koa and Harpy and Connect, amongst other things. We also have a dedicated Nest SDK for instrumenting Nest. And you can also just instrument generic frameworks that work through HTTP. All of these need basically the same amount of configuration, what I showed in this example here, and nothing much more. Okay. Let me stop sharing real quick.
Thank you, Francesco. Now I think we will open it up for Q&A. And first we'll run through some questions that were asked prior. So first one, what is a span? What is a trace? What are the differences between the Sentry JavaScript v7 and v8 SDKs?
Yeah, it's a great question. So trace is really the thing that connects basically one execution of a certain flow, right? So if you think about a node server, basically a trace is the thing that starts when the very first service boots, and it ends when the original request is finished. So this trace may span multiple spans. So a span is basically a single unit of an operation that does something and has a duration. And multiple spans make up a single trace. So I showed you this trace view where you see like all of the things that you saw in this tree view is one trace, and all the single bars in there are spans that make up this trace. Now, the concept of spans and traces existed both in version 7 of the SDK and in version 8 of the SDK. The only real difference in this regard between v7 and v8 is that we moved under the hood to use OpenTelemetry for how spans are actually created. So this is really like an internal implementation detail for the most part. The end result that you get in Sentry has been and remains spans. So this doesn't really change.
Thank you. So next question is there out-of-the-box support for OTel, OpenTelemetry?
Yes. So as I just mentioned, basically under the hood, the Sentry SDK uses a totally normal OpenTelemetry setup. So when you call Sentry init, we actually initialize an OpenTelemetry tracer, which means that any OpenTelemetry spans that are emitted anywhere in your application or any instrumentation that you add yourself will just be picked up by Sentry. So basically, yes, you can just add more OpenTelemetry instrumentation and Sentry will just pick that up.
How do you include distributed tracing between microservices using spans?
Yeah, so the really nice thing is that distributed tracing and connecting traces together really works out of the box without you having to do anything. So as long as any microservice uses Sentry, so basically you call sentry.init, they will automatically connect together. And this happens by, so any API request that one service makes to another service will get a Sentry trace header, which then the other service will automatically pick up and continue. It's all automated. You don't need to do anything about this. So really just install the SDK in all the pieces and everything will be connected.
How do you set up monitoring for a MERN stack?
Yeah, it's actually a good question. I maybe skipped over this actually a bit. So I showed you that when you set up Sentry, we automatically capture spans for HTTP requests, which is nice, but that's not the only thing where we automatically capture spans for. We also capture spans for database queries for most common database systems. So like Mongo, what is part of this stack basically would be automatically instrumented too. Express, as you've seen, is automatically instrumented. The React part, you can install Sentry React on the front-end part of your application. And again, then this will automatically talk to your backend and will automatically be connected. You don't really need to do anything about that. So the answer to this is basically just install the Sentry Node SDK on the backend and the Sentry React SDK on the front end, and you will be good to go.
And then how do you integrate Nest with Sentry?
Yes, so since we shipped V8 of the SDK, we had basic support for Nest, which generally worked reasonably okay. However, because Nest is pretty large and has a large user base and has some special concepts, we are currently working on a dedicated @Sentry/Nest.js SDK that's currently out in like a pre-release state. But this is basically will be the best experience to use Sentry with Nest because it really can do all the stuff that's specific to Nest in an ideal way.
And same question, but for Nuxt.
Yeah, also Nuxt has historically been a bit challenging to instrument. There was a community package for Nuxt 2, which worked well, but it didn't support Nuxt 3, which is the current version. So we are currently also working on a proper Sentry Nuxt SDK, which will support Nuxt 3 out of the box. That's also work in progress as of now, but we hope to have a usable version out in the coming weeks.
Great. Okay, well, those were the pre-submitted questions. So I will go through I'll ask Francesca to answer some of the questions that were sent over during the workshop. There are a lot, so I don't think we'll get to all of them. So if we are not able to get to them, please ping us in Discord. We have a lot of Sentry engineers there. I'll share the link in the chat to join our Discord. So one of the questions that came up is there a way to see what the actual parameters are being passed to Sentry when an error happens?
Yes. So basically, with the error, you don't just see the stack trace and stuff like this, but you also really see a whole bunch of auxiliary data. And this also includes request data. So stuff like query params and other things like this will be included in there. We automatically try to strip personal information on there. So if you have like user IDs and stuff like this, as much as possible, we try to remove them automatically. But generally, this should be automatically included with your errors.
Another question, how can you report custom events other than the ones sent from Express navigation?
Yes. So in addition to the automatically captured errors that Sentry will just capture for you, you can also capture errors on your own by using sentry.captureException. And you can just pass in an error in there or whatever you want to capture, and this will be sent to Sentry for you.
And Francesca, this may be putting you on the spot, and I don't know if you have an example of a session replay, but someone asked if they could see an example of a session replay. Is that something you have? I know that may not be uh,
I I
set
haven't
up yet.
prepared one here because session replay is like a front end thing. So um, you cannot use session replay with the Sentry Node SDK. Of course, if you have a Node application that renders HTML, you can run session replay on the rendered HTML that is served to your users. But in order to do that, you then need to still ship the Sentry browser SDK in your rendered HTML. So that's possible, but kind of like outside of the scope of this webinar, I guess.
Yeah, and I think we just shipped session replay for our mobile SDKs, and I believe we have a webinar next on the 31st. So that may be a good one to join if you're interested in mobile session replays. Another question, do you have any recommendations for using for serverless environments like Azure Functions? Where does the Sentry init go?
Yes, so we have, if you go to docs.sentry.io, you can find dedicated documentation for Azure Functions that should show you how to set this up in an ideal way. We have docs for Azure Functions, AWS Lambda, and GCP Cloud Functions. So you should find detailed examples for how to set this up on the docs.
Okay. Can the resources of the server be inspected to catch something like an OOM?
So what we provide is we call it ARN app, no, ANR, app not responding integration, which you can use. So this will basically spawn a separate thread and monitor the main thread and report to Sentry if like your main app basically freezes. So this would possibly report on out of memory issues, for example. Now I can't say if this will always catch all issues like this, but this should help often at least with these kind of problems.
Got it. Uh, all right, and this question was asked 2 times. What is the impact of Sentry on Node.js on the server with and without?
I'm gonna assume this means like resource overhead kind of impact. So generally running any kind of observability software basically will always have some overhead, like by design, it is doing something right. But typically the overhead of using Sentry Node is not noticeable. We try our best to keep resource usage to a minimum. And if you, for example, have like a really like sensitive environment or stuff like this, you can also opt out of certain things that we basically don't monitor certain things if they're not that important to you to keep the overhead to a minimum.
Right. We just have one more question left, and it's again about session replay, which I know is a little bit outside of this, but I think I can answer this. The question is, does session replay work to observe all user activity, or is it just user activity specific to when an error occurs?
So yeah, all good. I can answer this.
Yeah.
So session replay has been designed to see what happened before an error happened, but you can also configure it to just generally capture a user session. So there is a general session sample rate and a errors-based sample rate that you can configure separately. Generally, the way it works is we buffer what's happening, kind of, and we keep a buffer of the last minute or so of stuff that happened. And then if an error happened, we actually send this to Sentry, right? So stuff is observed but not sent unless an error happened in like the default scenario when you use error-based sampling.
Great. Well, Francesco, I think we were able to answer all the questions. Thank you, and thank you so much for everyone for joining and all your great questions. I expect an email from us with a link to the workshop, and then also some other resources to get started with Node.